Good morning, good afternoon, and good evening. A few days ago, I tried to press the button here on this power bank and nothing happened. You're supposed to see some LEDs here indicating a battery level here on the back, but nothing happened when I pressed the button. So I assumed it was the batteries were drained. I plugged it in and tried to charge it. A red light came on here indicating that it's charging, as well as one white LED was blinking. Again, that indicates that it's charging. Anyway, I came back after an hour and it was completely off. No lights were on. So again, I pressed the button and again, no lights came on. So then I brought it here and disconnected one of the battery terminals from the board, and I did some multimeter checks. And so I found some shorts here, basically where those three capacitors are. Let me point them out here. There's like shorts on these capacitors. And I also found another short, I forget where, but on another component here in this area. So anyway, then I remember that I have a thermal camera which I purchased recently. So I thought it would make a good video to use that and to check what's going on. Anyway, first I'm going to go under the microscope and show you with the multimeter where I discovered the shorts, and we'll proceed from there. I'm going to desolder the other battery terminals so we can work on the board with ease. Alright, let's go under the microscope and check what we have. Maybe light bulb here. Gonna go on diode mode. And let me show you where I found the shorts. It's untangled. Okay. So it's these three. Short here, both sides. I'm not sure if all these three are in parallel, but anyway. So all of these are shorted. And there was some other component. I just have my red probe on the casing here of the USB port. So for the ground. Let me see if this small one is shorted. Yeah, that one is also shorted. What about this big one? Yeah, this big one is also shorted. What about this one here? No, we're getting a diode reading 0.65, and the other side is ground. So this one is not shorted. So basically all of these here are shorted. This resistor is actually a low value resistor, so what else can we check? I think that's about it. So what is this one shorted up? This is way too far. It shouldn't be. No, I'm getting a diode reading 0.65 again. Okay, so now I think I'm gonna set up the thermal camera, and let's give that a try. This will be the first time I use the thermal camera to check for a short. I have used it in previous videos just to check for temperature. That's when I did my LED bulb repair. I wanted to see the temperature that the hot plate got to. But now I'm going to use it to check basically what's shorted on this board. Hopefully it'll work. So here we have the board, and there's not much going on. This is just reflection. Any orange, like this orange here, this is an inductor, the top of an inductor, so it's not really heat. Alright, let me plug it in. Trying to do this one-handed. Okay, and let's observe. It's in. Okay, I see something blinking right here, as well as right there. Let me put I have a lens, a macro lens. Let me put the macro lens and we can get in closer. Okay, so these are the three capacitors that I mentioned before. And pretty much it's the middle one, as you can see. And then here, there's this chip. 6 legs chip. Okay, so it's either this middle capacitor or this chip here. These are the two items that are shining brightest. Nothing else going on. Alright, switch views. So that was quite helpful because it has narrowed down our search. Let me unplug this to either this middle capacitor here or this component right there. Let's take a quick look under the microscope. So it was this here. It was the middle one here that was blinking, and this component right here. Let me see. 8205HA. Okay, I need to find the datasheet for that to see what it does. But I suspect I believe we should start by removing this capacitor and seeing if the short goes away. If not, then it would mean that it's the other chip that's damaged. So let's do that. Let's remove this capacitor. I reoriented the board so that it's more comfortable for me. Alright, well, I'm gonna go with hot air, 400 degrees, 50%, and let's see what we can do. Okay, that capacitor is out. So now let's measure if we still have a short. Okay, red probe on the ground, which is the shell of the USB port. And then, let's see, beeping on one side and not the other side. I think we just found the problem. This is the ground. This is now giving 0.487 reading. It'll go up as the board cools down. The board is still fairly hot. So we found our problem. Since there are 3 capacitors here I assume in parallel, we probably don't need to replace this capacitor. But I have another one of these boards. I'm tempted to check what the capacitor is, the one that's in the middle, and replace it. Let me do some offline measurement of the other board, and I'll decide whether to replace it or not. Since I have the thermal camera set up and everything, I figured let me do another scan just to see that the 2 hotspots are gone. Okay, here we go. I'm going to plug it in now. It's in. Now there is another, looks like another area that's blinking here. Ah, but the board is working. Let me show you what I mean. The board is working because look, can you see? See, the light is blinking here, but because there is no battery attached, I think it's not charging. So I think this is okay. Alright, let me see if I can measure the capacitor and I'll be back. I removed the capacitor from the working board and will measure it shortly. What you see now is the capacitor from the faulty board, and I just wanted to just double check that it's shorted. So we should hear a beep when we touch the terminals here. Let's see. 1, 2. There we go. It's definitely shorted. I just used a bit of this is just a bit of blue tack so that the component doesn't fly away. Alright, so this is definitely shorted. I'll save it here just in case. And this is the good one, or from the working board. Let's press it in a bit. And let me measure what capacitance it is, and I'll see if I have a replacement for it. You should be able to see the value here. Let's see, 1, 2. 21.5 microfarads. So it's around 20 microfarads, I guess. Let me see what I can find, because this one is going to go back into the working board. I'm not going to use it on the defective board. I'm going to put it back on the working board. And search for a 20 microfarad to put on the defective board. So I have one of these capacitor kits that you can buy off of AliExpress, but it only goes up to 10 microfarad, as you can see here, and we need like a 22 microfarad. Anyway, so I've been hunting for one from scrap boards that I have, and I finally found one 0805 size, which is the size I need for this board. So let's measure it together. There we go. It's around 24 microfarad, which will do just fine. So the next step is to install it in the board. I'm going to add a tiny bit of leaded solder and then reflow the component into place. Just like that. Let me adjust this one. Just like that. Alright, so now I'm gonna come in at 400 degrees, 20% airflow, Aten ST862D. Alright, now that it's holding, I'm gonna put a tiny bit of flux and hopefully jiggle it into place. There we go. Increasing the speed to 30%. And let's hope it dances into place. There we go. Let me remove some of the excess flux while the board is still hot. And then I'm going to put my pad just to cool it a bit. These are just thermal pads. They actually do make a difference because I can feel the heat on the pads and the board is cooler. This is what I'm talking about, just pads, thermal pads. I put a bunch of them together. Okay, let me do a quick clean up with some IPA. There we go. Yeah, it's quite cool. So now if we measure, let me remove the microscope out of the way. So now if we measure the capacitance, it should be back to, where was it? It was around the total capacitance of 90. I seem to remember like 90 microfarad or thereabouts. So now that we have that back in, it should go back to being around 90. Let's verify that. Yeah, there we go. 85, 84, but I think as it cools down, it might go up slightly. Anyway, it's close enough to 90. Alright, so I think this might be fixed. That's my soldering iron. Alright, so we'll come back and I will resolder the battery. There's the battery plus, battery minus here, and then we can give it a test. Actually, I can give it a test now without the battery, because the lights here should blink on and off. Okay, let's do that quickly. Where's my, here's my cable. Let's do that quickly and then we'll attach the battery. So I'm going to hold it the other way so you can see the LEDs. The LEDs are going to be blinking here somewhere. So here goes nothing. Yeah, on, off, because there's no battery. Alright, so I think this is fixed. Let me reattach the battery and we'll do a quick test. Alright, let me add a bit of flux to the battery terminals here. The D minus could use a bit more solder. Let me add a bit more solder. Okay, let's do the D plus. There's not enough heat. Let me boost. I'm gonna boost my soldering iron as opposed to replacing the tip with a bigger one. I could do that also, but this is easier. There's our battery minus terminal. And now I'll do the battery plus. And that's the battery plus. Plus minus. Red is plus. Blue minus. Okay, it's cool enough. Let's plug it in. And I'm gonna again turn it to the other side. Wait, let me do a bit of cleanup. Let me clean the flux from around the terminals quickly. Yeah, I need it. The other side. Okay, that's better. Alright, so I'm gonna flip it around so we can see the lights once again. I think now it should be one red light and then one blinking white light to indicate that the battery is empty but it's starting to charge. So let's see. There we go. It's exactly as I suspected it would be. One red light to indicate that it's charging, and then one blinking white light to say that it's charging the battery. Let me see what's the voltage on the battery. I'm curious. Before, when I measured before, it was like around 2.8. So let's see now, and I'm assuming it should be going up. So put this here, put this here, and let's see. B minus, B plus. 2.893, 94, 95, 96, 97, 98, 2.9. So it's certainly going up, which is a very good sign. Alright, now previously when this broke down, like I said, I had kept it for like an hour and came back and it was turned off. So I'm gonna leave it sit here for, I don't know, a good 30 minutes. And we were at 2.9 volts, and I'll come back after 30 minutes and we'll measure one more time, and then we'll declare this fixed. Well, it's been about 30 minutes, so let's see where we are. We left it at 2.9 volts, and let's see where we are. We are now at 3.69. Now, one thing I wanted to try, I forgot to put my USB meter to see how much current it's drawing. So let's do that now. So yeah, this board is supposedly capable of power delivery, and so is my charger. And so as you can see, it's drawing 9 volts at 2 amps, so the equivalent of 18 watts. Let me bring it closer so you can see it. There we go. So almost 9 volts at a little over 2 amps for a total of 18.7 watts. And once again, let's do a final voltage check from 2.9 to 3.97. Just a minute ago we were at 3.91, so it's still going up. So I'm going to declare this a repair, and hope you enjoyed the video, and I'll see you on the next one. Bye bye.